Hello and welcome to the shop. Today's topic, blinking LEDs. Wait a second. Why are there only two of them working? And that's the topic of today's show. So, I bought one of these little wang danglers and those LEDs over there, hoping that I could Wi-Fi control some LEDs. I had it working on a little AT Tiny 85 chip. This little guy right here working just dandy, and I thought, well, might as well try out the Wi-Fi chip. Plugged it in, and it says it's rated for 12 to 24 volts. And so I've got my laptop power adapter right here that is rated for 19 volts. And unfortunately, I don't know exactly why it popped it, but 19 volts was just too much for either this controller chip or for my LED strip, and we ended up with just the first two LEDs operational. I heard a little pop noise, and if I look closely, let's compare the two working devices. So let's just take a look here. We've got these two work, and this one right here. I notice that there's a little bit of difference on the epoxied or plasticized chip there. See how this one, the epoxy or the plastic is adhered to the top of the chip quite nicely. You can see it's black. And then this one, it's got a sheen going on. And then the next one in the line, it's nice and black. And then I found another one further along, which also has that little bit of sheen. And I suspect that the ones that have that sheen, here it is, that they know it would work. So what I'm going to do is I'm going to actually just pop these guys apart and see if, ooh, that looks like it could be a little burn mark there. See if I can separate these two out and then get the rest of the strips going. So what I'm going to do, I'm just going to chop out these two. And then what I got here is just pulling back the leads a little bit. We're going to chop up some heat shrink tubing to go over to the solder joints. I'm just going to bypass those 3 or 4 LEDs that were giving us trouble here. I'll just pull these back a little bit more. Where'd my other one go? And we'll strip these and solder them up. Got this handy tool. Oh, I gotta use it right. Makes it very easy to strip these wires. So we've got our known good working LEDs. Plug those guys in. They should flash. Excellent. Now, there's probably probably better ways than this, but I'm just going to go ahead and spin these together, matching up the white striped one with the correct pin, and then just spinning them together, because I'm going to hit them with solder and then cover them up with heat shrink wrap. Get back in there. Like so. And then come in here with our solder. And I'm just bending them over, sliding that solder connection right into a heat shrink tube so that we can then shrinky dink it. However, before we do that, why don't we go ahead, these are electrically isolated enough so that we can test the LED strip out again. And let's see if they don't light up for us. Ooh, that's a no good. Just the two. What did I do wrong? So I've got those connected correct. It could be that we're just not getting any signal past this chip. I don't see any indications that it would not pass electricity, but we are not getting anything else lit up in the strip. So I guess the next step before we continue is to see if the rest of the strip is functional, and so that will require getting one more of these chips operational. Alright, so I got my multimeter here from a long time ago. It's in DC 20 volts, and so what we're going to do is we're going to look at what the supply voltage is over here. So I'm expecting this white pin and this red pin are connected to the voltage source over on my little thingy-bing. It should be 5 volts or whatever the DC supply VCC is. And I gotta show you the meter, I guess. Huh? .65 volts. It's within tolerance, I suppose. It's functional. And then if I back that up a little bit, we're going to test for the same thing. So the way that this works is that the white is the same as that pin that has the stripe on it, and the red pin is the opposite side. And I'm assuming that they carried that throughout the entire LED strip. So here's the white pin, call it the white pin, and that one should be our neutral. And we'll check that, and we'll check the other side, making sure not to touch them together. Oh. There we go. Get our meter. Oh. There we go. And we'll test right there. So our ground and our 5 volts, 4 point whatever. 4.64. Okay, so we are getting power to the other LEDs. So the question is it, what is it? Are the rest of them just baked? Is that the question? I don't know. Let's look at this data line here. Let's see if we can get some information off of that. All right, so here's what we got here. We have a Salier logic analyzer, the Logic 8, a couple years ago. And I've got this plugged into my computer with these little breakout boards here, and what it'll do is it'll show us what's going on. So I have the black pin on here, which is the ground, connected up to the ground of my little circuit board here. And let's unplug this so you can actually see it. So I've got the black connected to the ground, which is that white wire. I have the brown pin connected to pin 0 on the AT-Tiny85 controller, and I have my software set to trigger on receipt of an uprising, an evil robotic uprising, a rising pulse. And then I have the next one in line. So it goes black, brown, red. I've got that one plugged into the output of these two LEDs. So we know the signal gets successfully to LED 1 and 2. It's number 3 that's having the issue. And so when I go ahead and run the capture, this is the kind of information that we're getting in the logic analyzer. I see some data, and it's on pin 1 or pin 0 of our AT-Tiny out. But what's coming through those two LEDs looks funky. So this is what is coming out of the controller. This is what is coming out of the string of LEDs. And if we zoom in, it's obvious that there is a lack of similar information. I'm not sure why the ground actually is pulled down. It could just be the way that I'm triggering. It's shows up as high, and then it's being recorded as a low. It's a ground, so it should always be low. But that looks like it's information. You know, the lights are flashing according to whatever this is in this sequence, and this one's not got anything. And I would expect it to be at least something visible there. Come on, zoom out. There's just a couple little, yeah. And the data out should also be offset from the input. We've got the way that these chips work is, let me get back to that. They're just wired in series. So whether it's a chip that's got an onboard die for the LEDs or these types of chips where I've got them, they just have a pin that goes to the other LED controller, and so that makes up the whole string. And so we are feeding in the data on, call it pin 4, and I'm expecting to see it come out on this pin. So I'm curious what's going on here. All right, so what I've done is I have just taken the signal wires between the two working LEDs. I'm going to take a peek at this signal and see if we can't capture some information. Perhaps this LED it's successfully displaying the information, but it's not sending it out to its output pin. So with this little guy, this is the orange one, we should be able to see what's going on. All right, capture. All right, now we've got something a little bit different. So this is our data in from P0 on the ATtiny85. This is the data out from LED number 1, and this is the data out from LED number 2. So we see the same information right here, which is okay. Well, that's okay. But then we don't see any information out of the second LED. So it makes me wonder, how are we getting information? Oh, well, it explains it right there because I have my things labeled wrong. Let's try this again. So I have it wrong, that's all. Just going to take off the red pin and the orange pin and swapperate them to match my labels. All right, that's important. So now I'm expecting to see LED 1, LED 2, LED number 3, and the output from LED number 2. So what we've got is, if we zoom in, we see that there is a slight offset. So the signal comes in, it's processed by LED number 1, and then it's passed off. LED number 2 gives out this info, but LED number 3 seems to be a no worky. And if we scroll past, yeah, it's not like it's just a little slow, expecting that little bit of delay. So this is the delay we were expecting. You know, it's processed by LED number 1, it's output by LED number 2, or those little controller chips, and so we should be seeing LED number 2 coming out right here. So here's my idea. Got our data and our power coming around, goes into LED number 1. I'm going to make a little bridge right between these two and see what happens. Actually, what happens if I just touch them together? I can't do it. 1 second. All right, so I went ahead and cut this line because when I tried to test it, it was actually pulling it low. But I can see that just by touching this jumper in, we get all the rest of the strip to work. So indeed, we had an issue with output from this LED right here as a result. So what I'm going to do is just solder that up. I went ahead and chopped out the bad one. Wrote a little label on it so I can still use it, but it's a bad output. So it is a no work for anything other than just indicating. And so I'm just going to repair the circuit by connecting up these little guys right here. and then we'll be back in business. What good is a video without a little bit of soldering? Everybody loves to make fun of everybody's soldering skills. I was talking to a guy and he said, you know, as long as you get the connection you need and it works, what does it matter? For us home gamers, at least. He's also working on super fine pitch SMD stuff. I think that's what he really meant. Anywho, so we're just going to bend over that solder lead, shove it into that heat shrink tube. We turn on our SMD rework on our Heiko. Oh no, this isn't a Heiko. I don't have cool tools like that. AUA 968. And we're gonna, oh, I guess we need some heat on that, huh? Waiting for it to come up to temperature. That's good enough. Yep, shrinky dink. Shrinky dink. Okay. Ooh, that was hot. Let's turn that off. And we want to now plug it in and see if it works, right? Where's my USB plug? I lost it in this mess on my desk. Ta-da! Dun 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 dun! Can you turn off, please? So now that we're in the Christmas mood, let's reflect on what happened here. This guy, I want to take it apart. Doesn't look like it has any kind of screws underneath the surface. I think it just probably pops apart here. This is one of those cheapy $15 controllers from Amazon that some seller has relisted from eBay, probably. When I say relisted, I just mean that they got it cheap from China somewhere. All right, so we're in. Oh, looky there. That's familiar. That's our little friend there, the ESP8266. Except it's the 8285 mod. So that means it's got, I don't know what that means. Does that mean it has the memory built into the didgeridoo thing? Let's see if we can find anything wrong with it. At first glance, no, nothing is visible. That would probably be our voltage. Let's see what we've got. An AMS 1117 H82 2MP. Where does the... Oh, there's more stuff. What the heck is all this fun stuff? No idea. But let's check that voltage regulator first. See what it outputs. All right, our quick Google search says it's by Advanced Monolithic, and it's a SOT23, and it's got 3.3 on it, so it's a 3.3 volt regulator. And so this is good. It's a 1 amp output to drop out blah, 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 blah. And so I'm wondering what could be wrong with that. Now, that's obviously doing the 3.3 volt for the ESP8266. What else could be going on here? All right, well, I found the smoking gun. It's such a simple thing. It's a manufacturing defect. See these hanging, flying wires right here? Focus! So, yeah, the A, we've got our VCC voltage, V+, tied directly to the LED pins. And also right next to it is the data pin. And what happened is that the LEDs must do their own voltage regulation. But what must have happened is that that data pin in the middle got this little wire pressed down on it. Now I actually remember holding this in my hands and just barely pressing down on it because I noticed that the connector was kind of cockeyed. And that's when I heard the magic smoke make a little pop noise as it was released. And I'll bet that one of those little tendrils of badly soldered wire just kind of gave all 19 volts over to the data line, which explains why we had issues. It was not expecting to have such high voltages across the data pin there. So what I think I'll do is I will try to resolder this the correct way, and we'll give it another try. So all I'm going to do is just hit those flying leads with a little bit more solder. Go ahead, tell me what I'm doing wrong. These are just the things that I do while I'm soldering. Oh yeah, lots of dwell time. I didn't wait for my soldering iron to heat up very much. Let's give that a second. Come on, buddy. I've just gone and made a mess. I think it's better than the manufacturer's mess. However, and then we'll hit the other ones. Oh, nice big blobs, but all of the freeform wires are no longer free. Oh, did I just bridge that? Oh, no, good enough. All right, so it's about as good as it's going to get without ripping that all off. Doing it again. All right, well, this lines up with the logo on the thingy-ding, so we will get this. Alrighty, let's try this again, see what's going on here. I'm going to go ahead and it's not connected yet to my LED string. We're going to plug it into power. Let's see if it lets any smoke out. No smoke. This is a good thing. Well, while we're waiting, we've got our software. Let's go ahead and click Connect to Wi-Fi Network. What is this? Oh, are you serious? This is not going to work for me. All right, LED net 8F9C4D. I betcha that information is somewhere in there. Like the MAC address. Let's connect to it and see what happens. Unsecured network. I don't want to get a virus. Dun, dun, dun. 10.10.123. Let's see if we can't get get connector rated to that. Let's see what it goes. Wonder if it's one of those things where it sends information based on what you append to the end of it. I mean, for now, I could just blow more LEDs if they don't work. So we're giving 19 volts to all these just because I'm trusting this label. Do I trust this label? I have no idea. What's the worst that can happen? Whew, they are bright. They're all white. No, they're starting to tick off different colors. Randomly. Some greens. Oh, Ooh, flash mode. Is that a designed thing? Or are they all dying? I can't tell. Whoa! All right, something's on fire. All right. That was exactly what happened before. Ooh, another one smoked over there. All right, well, so much for that. So I guess if they all go bright white and they start flashing lights, then that's not a good thing. Oh, All right, well. Ooh, this smells fun inside too, again. So I hadn't broken this before, but... Ooh, ba-ba-ba. I don't see anything, but it's definitely... These LED strips are definitely not designed for 19 volts. Oh! Yeah, a little bit too much voltage. I guess I could have read that, huh? Only 3 times what they were needed. 3.5, 4 times. So now we look for all the blown up LEDs. Okay, back to the AT Tiny controller. This is where we're at. We have 1, 2, 3. Oops. Okay. So we can probably safely say that the output on this LED is bad. Or can we? Ooh, this one has let out the magic smoke. Dun, 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 dun. Dun, 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 dun. Ooh, interesting. This one seems to be stuck in a state of blue. I'm not sure what that means, but that is way further down the line here. But its neighbor just prior, ooh, there's another magic smoke. Oh, let's unplug these and look at these LEDs again. Ooh, it smells. Something smells. So this one, not only is it reflective in there, it's brown. It let out the magic smoke and some shmoo. So we've got, I thought there was 2 of them somewhere. Now I've noticed something interesting in troubleshooting these. So I only have the 2 LEDs that are functional. I've gone ahead and chopped the wires off here. But what happens is if I were to just pulse the power to the rest of the LEDs, they all light up, or at least a good number of them. Some of them do not. Take in case in point the particular LED that I have right here. I'm going to make a bet that any of the ones that light up red are going to work. And the ones that don't light up red, this little application of power, don't work. So I'm going to go ahead and just chop out one LED at a time that I think is broken based on this test. So I'm going to chop this one out, and I'm going to assume that the second one is also out because it does not flash. But the third one, where's the third one in the shot here? It's hard to see with the lights. Disco Party. You can just barely see it. That one right here is lighting up when I apply the 12 volts to it. So I'm going to go ahead and do that. All right, here we are. I've chopped out those 2. I tested them individually, and indeed, these were the 2 that didn't light up when I hit them with, or they did not flash red when I hit them with power real quick. So I've chopped them out, moved on to the next. You can see the ones in the background. They're still flashing. You can't really tell, but I promise all of them are flashing in the background there. We'll connect up the power. And then once we give it the data, ooh, there we go. We got all our lights on. So I think there's still a few that are bad in this batch. What I'm going to do is try and follow this rat's nest and figure out which ones are which. Ooh, we don't want to do that. I've already had enough LED poppage today. So we go this direction. Okay, so right after this LED that's been stuck on blue, we have a no light. So I'm going to say that the output of that is bad. So I'm going to go ahead and chop this LED out. This one's blue, but this one's also, I realized, it's let the magic smoke out. So we're going to chop out 2 LEDs and see what happens. Actually, I'm going to just try chopping the pin here first. I'm just kind of curious if by chopping this it will do anything different. No, nothing different. Oh no! In all of my whatnot chopping and plopping, I have inadvertently released too much magic smoke today. This one's going to, unfortunately, not allow us to continue. I am afraid it's not working anymore. Oh dear. Something is dreadful. Woo! Made a noise. I think it's letting the magic smoke out very slowly. Well, this one has seen better days, and so we send it off to the great scrap heap off to the side so we can rescue parts off it later. And we'll move over to another one. I got to get some more of these on order. They are DigiSpark clones from the great Far East, and I think they cost all of like $2 or $3 a piece. They're really handy to have around. They run micronucleus or whatever it is, and they have a very simplistic method of programming them. You don't need any USB, or rather you don't need a serial connection. It actually emulates it with a special driver. Getting it installed sometimes can be a pain because you have to use an older version of Arduino in the libraries, but once it's set, it's really neat to have quick access to tools like this. Anyway, we're going to continue here. Wait, I take that back. The one that blew up was the Chinese knockoff. I actually bought an original DigiSpark, I believe. So this one looks real. Not 100% certain, but it does have the logo in the right spots. I'm going to say this one has a high likelihood of being real. Maybe I'll see if they still sell them and throw a few extra bucks their way. Revision 3. Now, to make things easier for myself, I soldered on pin headers. But of course, these are male pin headers. And I have wires. So what I could do is just chop these and use some of these. What I really wish I had was something like this. This would work. This is for a larger Arduino. It's a screw shield, and it sits down on either side. But I don't have one that's just tiny for my little AT-Tiny5 stuff, so maybe that's something to make up. So all I'm going to do is just take this little female pin header, and then I only need 3 pins, so I'm going to slice it right between on pin number 4. And that'll give me just what I need. I need this one for pin 0, and this one for ground and VCC. More crappy soldering. Yeah, a little bit of solder on the tip. And then this one on the right is the... Ooh, I need to trim that a little bit. It's a little too long. All those little lovely bits all over our electronics. And then we're gonna go ahead and tin these. Don't breathe this. And then got our ground connection right here. Tin these two. Oops, too much solder. That's the blow and smack method. go. A little too much on there. Oh, let's tin this little guy. A little tin soldier. All right. Well, that was horrible. All right. All that to get us back to status quo with the two LEDs here that are doing their thing. So you remember that thing where I said if they were flashing, they're probably broken? Well, I don't think that's true. Because I can clearly see that some of these are not flashing with the red. And I think that is for some other reason. Because I put them in party mode and they all freaking work. So that's a good thing. So I'm going to solder this whole string back up after identifying all the broken ones that I blew up for the second time, being an idiot that I am. And then we'll have a working string again. Also, I think I need to do something about this workbench. It's a bit much. It's gotten a little bit messy. Maybe we'll do something about it. And it burns, 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 the ring of fire, the ring of fire. All right, so we're back to status quo. I did not get to the bench yet. We'll get to that by next time. But let's just think about what we've learned here. So, whenever you're plugging in a WS2811, WS2812 device, it's advisable that you use the designated voltage inputs. So on here, it says so very clearly right there, 5 volts. I could have avoided a lot of headache by just reading. Then again, I wouldn't have learned how to troubleshoot and practice my soldering skills, which I don't really need to practice, but yeah. Anywho, so we now have 5 fewer LEDs on our strand. We needed to trim the strands anyway, and we've got a couple that are functional but not exactly 100%, and we've got a handful of ones that we let the shmoo and the magic smoke out of. So, I mean, we could poke around inside. Maybe we could rescue the actual LEDs, and maybe the controllers are just bad. But do not trust the label on any kind of device. Just because it shows you voltages doesn't mean you should trust them, especially this cheap Chinese stuff. So I think this thing's actually fine. It was just the output voltage that's an issue. So I think what I will do is actually solder my own headers up on here and program it myself with my own software, and then get a proper label for the top and a proper voltage regulator in line before it goes out to these pins, and then we'll try it again. See y'all next time. Subscribe.